Okay, so yesterday in our graphics beginning, what we did is we just used one of the classes, and basically right now we have two classes up here. But one of our classes, which has main in it, basically instantiated a graphics object. Okay, so we're going to create a graphics object called graphics1. Okay, so we made this thing called graphics1, and it's a class. So you're going to have properties and methods. But at first there was nothing to it. But then when we actually created it, we added an important thing to it that really creates the power here, is we had it extend something called Jframe. Okay? So what this means is a graphics1 is a Jframe. Jframe is a library that comes from another library called Swing, which comes from another library called JavaX or JavX, which is an extension library. So it has extended this library to this library to this library to create graphics1, which is a Jframe. So graphics1 is a Jframe, which gives it the ability to have all the graphical stuff that we need to do with it. Okay? So since it is a Jframe, when we wrote our constructor, we can call on methods that are already built into it. And one of the methods we called on was the method setSize, and that's when the bell rang yesterday. Let's write one other method to at least get this going. This dot set visible to be true. Now, one strange thing about Jframes is by default, they will start invisible unless you tell them to become visible. So the default setting for Jframe is I'll make it, but it will be invisible. So at this point, you could play your code. So what we're saying is I want you to set my size to be 500 by 500, and I want you to become visible when you run. So what happens is when it runs its constructor, there it is. It slowly appears. So now we're kind of at the point where we were in C# right at the beginning last year. We have what we called in C# a form. In Java, they happen to call it a frame, but it's the same thing. It's basically just a window, so to speak. And it has some of the features that you'd expect. You can resize it, you can minimize it, you can do all the stuff that you'd expect a Jframe or a form to be able to do. But here's a weird thing. When you exit out, like when you X the red corner, it actually is still running. You can notice down here at the bottom that your program is still running. So in order to actually shut it off, you're going to have to click on that little X down there. Strangely, again, the default setting for Jframe is when you exit out, it doesn't shut down your whole program. It just makes that form go away, and the program still runs. Now, that being said, there's nothing else causing your program to stop running at this point. So we're going to add one more line to our constructor here to fix that. Okay? So when we use the keyword this, again, what we're referring to when we use that keyword is what will be the object of this class. We actually know that in our main, we called our object graphics1 with a lowercase g. Okay, but we don't know that when we're building the class. So this stands as a placeholder for what will be the object when it's instantiated. Okay, so that's good. So now we can call on methods within that class. But before we do, I could have used a different keyword other than this to do that. Can any of you think what other keyword would have worked here? Right. I can also use the keyword super. If I use the keyword super here, then it's referring to its superclass, which is Jframe. And remember, graphics1 is a Jframe. So both of those words in a lot of ways can be used interchangeably to refer to the current object. As well, one last sort of thing, you actually don't need to put the keyword this in most cases, I could have just said set visible without the keyword this. It would have worked as well. But again, as a coder, you may want to start sort of writing code that's readable not just to others, but to yourself. So I'm going to use the keyword this, dot set, and this is called the default close operation. Okay? Very tricky to type that if you just try and key it all in manually because of the camel casing going on there. So again, I would strongly recommend you use Control Spacebar to help it write the code for you. What goes inside the brackets, what the parameter for this method is what I should do when I close. And it's actually a number, but we don't know what number I should feed it. So what I have to do is pull out a constant. So I'm going to do that by going Jframe dot, okay, and here are some of the things that a thing can do. It can dispose on close. It can do nothing, which is what it's doing now. But the one I actually want is exit on close. Just pull back a little bit so you can see that. Okay, so what this says is exactly what you'd expect. It says, okay, when you make me a graphics 1, go to the constructor and it'll tell you how to make a graphics 1. And by the way, a graphics 1 is a Jframe. So when you're going to make a graphics 1, you're essentially going to make a Jframe. Okay, give me the instructions. What should I do when I make a graphics 1? Well, the first thing you should do is make it 500 by 500 length and width. Okay? So it goes, okay, well, I can do that. I can make you a 500 by 500 Jframe. Second thing I want you to do is make sure it's visible. Oh, okay, I'll turn it on so that the user can see it. And then the third thing I said to do is because it's a Jframe, it's going to automatically have one of those little bars at the top. When they close that Jframe, I'm going to set it so that when the Jframe is closed, I want the whole program to exit. Now again, I could have changed that. I could have said do nothing right there, and it would have closed this window, but the program itself would have kept running. That would have been an option. I could have said, there's other things I could do. There's one called dispose on close, right, and stuff like that. Notice again what you're seeing here is the style of code that you're hopefully used to is the style of code that's kind of standard. The fact that you see this in all capital letters with underscores might tell you that that's a constant, and you'd be right. That's exactly what it is. It's a constant. So your style is matching their style. Because now that you're working with graphics, a lot of what you're going to have to do is work with other people's code to make this happen, which is fine. But now I run this. Now, actually, I got to shut off the one that was running before, so I forgot to do that. I'll run this one. I get my Jframe. There it is. And when I exit out, the program shuts down. Perfect. Which, by the way, now shows you how, back here in main, I could have actually made 2 of these. I could have made a graphics 1, and I could have made a second one right here. Don't do this, but I'm just saying, I could do that, and now when I run this, I get 2 of them, right? I get one and then another one. Because you're in charge, so you're creating as many Jframes as you want. However, if I X either one of them out, the whole program shuts down because that's what I told it to do. I told it, when you X one of them out, okay, it exits. Now again, if I said do nothing on close, if I would have put that option in, now I got 2 of them running, or whoops, I forgot I took that out. Shouldn't have taken that out. Sorry, go back to here. Make 2 of them. They have to have different names, so I give them different names. Run it. So now I got 2 of them. I got this one and this one. But now when I X this one out, it does nothing. It does nothing on close. This one does nothing on close. So that wasn't maybe what I wanted, right? So then maybe I want to think about, okay, what about dispose on close? What does that one do? So I'll run that one. I have this window and this window. I X one of them out, the other one sticks around. Because it just disposed of that one, but the program keeps running. Now here's the other problem. I dispose of this one, It's gone, but the program's still running, right? So now we got to kind of build logic into how this program will actually it did shut off. It worked. But it was smart, figured it out. Okay, so anyways, that's some of the basics there, right? Is how I can get this thing to do stuff that I want. So let's get it to do a couple other real quick things. I'm going to leave this line as last just because it kind of feels like it should be last. It doesn't need to be, but I'm just going to put it as the last line. That being said, as we work through graphics, the order in which you execute some of these lines will become important later as we get more advanced. But let's try another one. This dot set, and here's another good thing about Java is a lot of the methods will start with the word set because you are changing something. When you want to get a value, like if you just want to read a value, you're going to find a lot of the methods start with the word get. Okay? So Java makes use of a lot of what are called setters and getter methods, whereas in C#, they kind of combine both of those together. If you think about it in C#, if you wanted a form to become invisible, you'd say form.visible equals true, or form.visible equals false. And that would work, right? So let's say you had a form in C# called x. You'd say x.visible equals true. You may recall lines of code like that in C#. But let's say you wanted to figure out whether or not the form was visible. So you'd say y equals x.visible. You could have a line of code that looks like that, and it would read whether or not it was visible. So assuming this was a Boolean, it would put the value in there. This is two different operations, right? Here I'm placing the true into the visible. Here I'm reading the visible out of x. Here I am getting a value. Here I am setting a value. And here's just a subtle but important change between the two programming languages. In Java, they're a little more specific. They like to use the word set to specifically mean I'm setting it, and the word get to specifically mean that. So their Java's a little more specific. I kind of like that as a programmer. It's a personal choice thing, though, whether you're... Okay, so anyways, let's try another one. I'm going to set the resizable to be false. And this would be what you'd expect it to be. When you run it, now you can no longer resize this frame. It can't be resized. Okay? Get rid of the second one here. So now I cannot resize that frame. If I set it to true, then I can resize it. You'll notice as well it does something automatically. It'll automatically gray out the maximize button because I can't resize it. What's the point of having a maximize button? Now I can still minimize it. That doesn't change the size of it. Okay, now as well, unlike C# in where you guys worked last year, you were building programs just for Microsoft Windows. But that is not the case with what we're working on right now. And recording again. Okay, here we go. So we'll try one more. This dot set title. Now, here again is something that's useful to you using an IDE like NetBeans or Eclipse, is now that you're using other people's code, it's important to know how to use that particular piece of code. So when I'm going to use something like set title right here, it's important for me to figure out what exactly are the parameters here. What are the parameters for this method? Which is why the Java documentation is crucial here. So by bringing up set title and using control spacebar, I can actually read that the parameter for this method is a string called title, which means it sets the title for this frame to the specified string. It's pretty self-explanatory, yes, but not all of them will be. It'll be a matter of you kind of researching. So if I just put graphics 1 right here, something like that, let's see if that does what you'd expect it to do. So I run it, and sure enough, now it's showing up right there as the title where you'd expect it to be. Okay? So using these methods is incredibly powerful. You don't have to do much work to make the graphics happen, but you need to be aware of the mechanics going on. You need to know what a method is. You need to know what a parameter is. You need to know how to read the Java documentation. You need to know about classes and extensions, which is why I've come to graphics last, because now you do have a deep understanding of all that stuff. I hope. Okay? All right. So this was cool, but a Jframe is nothing if not a place to put actual components on. That's going to be the point, right? We're going to want to be able to draw like buttons on here, like, you know, okay. We're going to put a label like hello world, right? I mean, this is kind of the stuff we did at the beginning of grade 10. I know some of you guys want to put a little fancy picture on there, probably a little graphic. All kinds of stuff like that, right? You want like the button to actually work and do stuff. That's me back shading it, right? So you want to be able to do all that stuff. I get that. And so I'm going to show you how to do that, okay, right now, obviously. But I'm going to preface this by saying when you learn that in C#, it was through a visual interface of you dragging and drawing stuff on there. I'm not going to show you how to do that yet. But I can tell you that NetBeans can actually do that. Okay, I'm just going to show you this real quick. I'm just going to quickly make a new class. And we're going to go into more detail on this later. But I'm just going to quickly just do this to show you that we will eventually get to a point that looks like this in NetBeans, where you actually have a visual interface where you can take buttons and drag them on there, where you can take things like radio buttons, where you can resize them, where you can find a properties window to change the properties. That exists in NetBeans. And what it actually does is it ends up writing code for you that looks very similar to the code that we're kind of learning here in some ways. For example, here's a set text method that looks very similar to stuff that we were just working on. Okay? So that exists. That can happen. We're going to get there. But before we get there, I'm going to show you how it's done without using the editor. So the next thing I want you guys to do is inside your class, Graphics 1, we're going to make some properties. Okay? They're going to be private properties. A private property, and it's going to be called a JLabel. Okay? So here's what you're creating, something called a JLabel. The J is capital, the L is capital. When you use this thing called a JLabel, you will notice that it will import it automatically. If it doesn't, it'll probably pop up a little light bulb. And here you can see that JLabel is imported from the same graphics library that Jframe was imported from JAVX Swing. So this thing called Swing has a ton of graphic stuff sitting inside of it, which is the point, right? That's something we want. So we need to give our JLabel a name. What I'd actually suggest is you use the same style of naming that I taught you last year. This is not a Java standard, but I think it is a useful thing. Something like this, LBL display. So we're going to make a label to display stuff on, and we're just going to call it LBL display. Okay, so now in theory we have this JLabel that's going to go on to our form. But even if I told you that, you'd want to know a little bit more about it. You want to say, well, how big is it going to be? Does it have text inside of it? What colors? Does it need to be colored? Like, what will this JLabel look like? Well, right now, it looks like nothing. It has no value to it whatsoever. It is in the constructor that I'm going to actually give it some actual content to it. So the constructor is used to build your graphics objects. So I'm going to do that. I'm going to say LBL display equals a new JLabel. So that's where you use the keyword new. And new is where it actually grabs memory to use this JLabel. When I create a new JLabel, it will call one of the constructors to construct it. Now remember, this is not your code. You're using somebody else's code to build the JLabel. And here you can see there's like 6 constructors that you can use. One of them is the default constructor, no parameters. One of them uses a string of text. Oh, that makes sense. So when I make the label, I can put text into it. So if I wanted to say hello world, I can just give it that one. But notice the one above it. It can also build a JLabel with a picture inside, with an image inside of it. And then the other 3 at the bottom are kind of variations on those. Image and the alignment. You can have one that has both text and an image and an alignment if you want. Alignment just means where is it lining up inside the JLabel. But I wanted to stop there for a second. I'm just going to put the default constructor for now and point out that JLabels are a way to display images as well. And here's where it gets a bit weird. The first time I learned Java, which wasn't the first programming language I learned, I had an issue with this. Because if you think in C#, when you built a Jframe in C#, and then you drew a little hello world label on there, and it was a little label object that looked like this, and then when you wanted to put a picture in C#, you would often put this thing from your toolbox over here, remember the toolbox? Actually it was over on that side, called a picture box. Right? There was this picture box thing that you could put on there. That makes sense. But in Java, pictures can also be part of JLabels. And the first time I learned this, I'm like, what? This doesn't make sense to me. So I went and read about it. I read the documentation of the programmers who built the JLabel. And this is how they described it. They said, imagine a can of soup. I know, this is corny, but stick with me. Don't back off on this. On a can of soup, when you buy a can of soup, there's a label. Right? They stick a label on a can of soup. And on that label for the can of soup, there can be text. As well, there can be pictures on the label. So when we designed the JLabel object, we designed it like the label on a can of soup. So you, the programmer, have the flexibility of putting just a picture on there, just text, or a combination of pictures and text to meet your needs. I'm telling you, that's what they said. As corny as that is, that's what they said. So what you can think about right now, and by the way, this isn't the only way to display both text and pictures in Java. This is a way. Think of the JLabel as both the label you're used to and a picture object. So let's make a second one up here. Let's make a second one up here, private JLabel. But this one will be for picture. So why don't we name it appropriately? IMG picture. So now I have 2 JLabels, but one is going to be used just as a label for text, and one will be used just for a picture. Okay. I'm following you, Wux. Let's go. IMG picture equals new JLabel. I'll use just the default constructor. Okay. So here's what my class now has. My class, in theory, has these 2 objects ready to go. In theory, I have instantiated those 2 objects. So now they're taking up some amount of memory. But it's still not really enough. I really don't know what I should put inside of that thing or what I should put on that thing, and where should they go on this Jframe. I don't really have a place to put them yet. Okay, so that's the next thing. Let's get started with some of that. So here you can see the coding is a little more specific than it was in C# where you could just drag and drop. You can do that in Java, but I'm showing you kind of what's going on behind the scenes. It's like that in The Wizard of Oz. They're pulling the curtain back and you're seeing the way the wizard works. All right. So let's take LBL display. That's our first label. Okay, and it's just for text. So I'm going to say dot set text. Oh, that makes sense. Could do that. And it takes a string. Okay. So I'll just, traditional hello world or something like that. So I'll just put the words hello world into that text. That works pretty good. Now, for the other JLabel, I have to create, and we saw this a little bit in a previous unit, to do a form of pictures, I need something called an icon object. So I'm going to make an icon called icon. And by the way, the icon can also signify, it's for pictures, but it can also signify one of these, like the actual icon. That can be used there as well. Equals a new, this is a bit weird, it's not new icon, it's new image icon. Okay? And it has its own constructors, one of which is a file name. So I'm going to just put quotes there for now. Now icon, it didn't automatically import. I actually have to hit the light bulb button and add the import. So now, up here, you see what's happening. Now that you're going to enter the world of graphics, the import section up here is going to get bigger. It's going to keep importing more and more stuff as you need it. It'll go, oh, well, this programmer wants this piece of graphics, and okay, I'll put that in there for you. Okay, so it just keeps adding as needed. So at first it just needed a Jframe, then it needed a label, then it needed an icon, and then it needed an image icon. So it'll add them mostly as you need them. Okay? All right. So now I've got the icon. So in theory, I can now go to img picture dot set icon to be my icon. So that should drop the picture into the other one. So now I've got text in one, and in theory, I've got a picture in another one. The problem is I need to put the name of the picture right here. Okay? And I need the picture to be in a location where it can find it. So, time for you guys to go find a picture. Okay? So I'm going to go online. And what I'd actually maybe recommend is, just because it might be kind of fun, an animated GIF. The icon object can use a couple different graphics formats. It can use JPEG, it can use PNG, and it can use GIF. It might actually be able to use a couple different ones, I don't know for sure. But I know it can, for example, use GIFs, GIF, which stands for Graphic Interchange Format, and the animated versions as well. So I'm going to do a quick Google search for a simple animated GIF, and then I'm going to have to save that graphic. Okay? Now, again, wow, the internet is not working out for me. Okay, here we go. So I'm going to go to Images, Animated GIF. There's no shortage of those on the internet. Dancing Banana, oh, for sure, that's the one I want right there. It's peanut butter jelly time. What? Come on. View image. There we go. That's the stuff right there. So I'm going to save this graphic. Okay? Now, where you save it is important, because when you tell Java where to get this graphic, you have to be specific, right? So for example, I might recommend that you guys put it, for example, in your computer folder, something like that. Like for me, mine's called lwalks at H. Okay? I might also recommend you rename this. So I'm just going to call this pick, and I'm going to save it in this folder called lwalks. To me, that works well. Okay? And I'm going to see, is that where it is? So I'll go to Computer. I'll go to lwalks. And in theory, that picture should be in there. And there it is. I can see it right there. Pick. We did this with the previous one. That was our matrix animation. So there's pick.gif sitting right inside of the H drive. Perfect. That's now going to be easy for me to code. H:/. Now remember, when you put a slash, it means something in Java. So you have to put two slashes. So it's a slash and then a slash. So it's not like slash new line. And then I put pick.gif. So in theory, it should be reading that picture now from its proper location. Okay. So it seems like I've got everything all set up properly. I've got a label set up with text inside of it. I've got another label set up with an icon, which I know to be a picture, inside of it. These two labels are ready to go. But now I have to put them inside of the Jframe itself. Because if I run this right now, that's not enough. It'll work in the sense that it'll still make the Jframe, but the two things I built are nowhere to be found yet. So in order for it to actually do this, I need to kind of get a little deeper into how things are added to a Jframe object. A JFrame object is what's called a container object, which I hope makes sense to you. It is an object that can contain other objects. So the JFrame can hold things like labels and buttons and other things. It can be a container. There are other container objects, right? So for example, there's one called a JPanel. And you can actually put that inside a JFrame. So there could be a panel there, and there could be a panel there. And these can be kind of hidden objects, and you can use them to create layouts and stuff like that. It gets more complicated quickly, but essentially just know this, that we need a way to contain our objects inside of the JFrame. So we have to add one other thing up here. We're going to add something called a private container object. And we'll just call it container. And by the way, you don't have to add this object, but I'm doing it just to demonstrate this to you guys. Notice the capital C here implies it's the class. The lowercase c here implies that it's the object of that class. And I'll use the light bulb to import it. Okay? So now we have one more import up top here. But I want to stop for a second and talk about that import. What do you notice that's different about that import? The library, yeah. Whereas all the other ones, all these ones, all came from the same place, swing. This one's coming from something called AWT, but that's not the only difference. The library before that is different as well. This says Java, whereas these ones say JavX. Okay? So I want to take 1 second to just kind of talk about that a little bit. Okay. These are the two big libraries that come with Java. The Java library and the Jav extension library, okay, are two big libraries. This one's basically called the core library, and this one is called the extension library. These are just the two big ones. You can bring in multiple Java libraries. Some companies make their own big libraries, obviously, that you can use for these things. But there's another important difference between these two libraries. This one is called a heavy weight library. And this one, contrarily, is called a light weight library. And I just want to talk about what that means for a second, because it's kind of important in the world of graphics. Because from these libraries are derived other libraries, right? So this one, for example, comes with swing inside of it. It's not the only library inside of it, but that's the one where we're pulling all the stuff like Jframe and stuff like that. This one had one called AWT inside of it. By the way, I'm going to have a little contest now. Can you guess what AWT stands for? Don't say it, grade 12s who might know. I'll give you the W, think of the W first. Window, right. Okay. The T is when you're making something, you need a bunch of these. You often have a box there inside of. Tools, yeah. It's actually called toolkit. So it's a Windows toolkit. And the A, you wouldn't have probably guessed this one, stands for abstract. Okay? So it's a bunch of abstract tools for working with Windows. But it's not Microsoft Windows that it's talking about. It's just talking about the idea of a window, which Mac uses too. Actually, Mac was the first to use it. Okay, Microsoft went, oh, that's a good idea. Let's steal that, right? And then they even named their company after that. But it's the idea of that. But here's where the heavy and lightweight comes into play. Okay, when you go and make some sort of we're going to build this JFrame, and we're going to draw a JLabel on it, and we're going to draw a button on it. Okay. Java has to think, okay, I'm going to build this for this programmer. What should it look like? Am I running on a Mac? Because if I'm running on a Mac, this little X thing's got to be over here. And if I'm running on a Mac, I've got to kind of round off the corners of these buttons, because I'm a Mac and I want to look all fancy like. So I got to round those corners. But if I'm running on a Windows machine, oh, okay, well I gotta draw the X over here, and I gotta make the buttons look this way. And wait a minute, it's not only Windows, it's Windows 8, so I gotta pick up that whole Metro style, blah, 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 blah. I have to think about where am I drawing this thing? That takes time for the computer to do that. That also takes code and a whole bunch of if statements, and it essentially puts a lot of extra code into your code to try and mimic the environment it's on. In other words, your program is a lot more heavy because it's added code in to really try to mimic, there we go, the environment that it's in. Whereas lightweight code goes, you know what, I don't give a crap where I'm running right now. I don't care if I'm running on a Mac or PC. I'm just going to look the way I want to look. This guy's like rebels that hang out by the smoking doors out back. They're going, I don't need to listen to you. I don't listen to the man. I'm just going to look the way I want to look. So the simple explanation is lightweight components do not try to mimic the environment, whereas heavyweight components do try to mimic the environment. We'll come back to that a little bit later. There's going to be more detail there. Okay. So, we've built a container that will try to line up our objects in the environment that it's built in. Okay, so now we're going to use this container. And we're going to use it first. Here's where order does matter. We're going to set up this container ahead of time. Container. Now, the container object is not built brand new. We don't say equals new container. Instead, what we do is we say equals this. What's this in the context here? The Jframe. Dot get. We're getting. Now you'd think it's get container, but it's not. It's get content pane. Now notice pane is spelled P-A-N-E, not P-A-I-N. That's what I experienced teaching you guys. No, where have you seen the word pane, P-A-N-E, in a different world other than programming? It's what? Glass. That's right. Glass like in a window, right? See all this stuff kind of worlds colliding now. Anyways, so I've got, what I've essentially done with this line of code is I've taken the Jframe, which is really the graphics 1. It's the same thing, because the graphics 1 is a Jframe. And I've attached the content of it to this invisible container that's already there. Cool. Now that I have the container, I can use the container. Pardon me. So now down here, after I've built my objects, I just go container dot add bracket, and I add the things I want to put inside the container. So I want to add LBL display. I want to add that to my container. I want to go to container dot add img picture. So I'm going to add those two things to my container. So I've already built them. I've already built a nice JLabel. And I've already built a nice picture. And now I'm adding them to the container that I set up ahead of time. All right, time for a run. Let's see if that does it. Look at that. I got my picture. But where's my label? I don't see my label. Do you guys see your labels? Okay, so we're kind of there, but not quite. Because think about what we've just done. Think about it if you were the computer. You've given it tons of good instructions. You've said, build me a Jframe, build me a label, build me another label, create an invisible container and attach it to the Jframe. Then I want you to put the image in the Jframe, and I want you to put the thing in the Jframe. But did we say where to put them? No. We just said, put them on there. So chances are, they're over top of one another right now. That they might be overlapping one another because we just said, stick them on there. I don't care where you put them. Put them wherever you want. And actually, I'm going to change one line here. I'm going to change resizable back to be true. so that maybe if I stretch this thing around, maybe I can find it on there. I can't, but what do you see? Something interesting happening here. Notice as I stretch the screen, what's happening to that image? It's kind of positioning itself. So that tells me that somehow Java's trying to lay things out for me, but it's doing it in a wacko kind of way. So we're going to add one more line up here after container here. We're now going to also go to the container dots, and we're going to set something called the layout manager. And so we're going to use a method called setLayout. Setting the layout is how it positions stuff. So I'm going to set the layout, and you can use the word null. That's the one that's by default already there. But instead, I'm going to use a different parameter right here. I'm going to say new flow layouts, and just leave the code like that. A new flow layout, which by the way will be imported. It will now import that as well. And notice where it imports it from. Now I'm going to run this code. And now I can see my label. It's now been given enough information to actually position stuff. Now, for those of you who are finding this really confusing right now and really tricky, the good news is I've already shown you that there is an easier way that's very similar to C#. But I got to be honest with you, a lot of programmers, I could easily pick Daniel as an example, don't use those auto designers to design GUIs. Why? Daniel, answer the question to the grade 11s. Why? More control. That's exactly the answer I would have given if you would have asked me. I like to have the control myself as a programmer. And so I'm not saying there's anything wrong with those. Sometimes you can make a combination of both. You can use sort of the designer a little bit and then code a little bit yourself. That's really the way that a lot of people will work. Anyways, I just want to show you one more thing about this flow layout before we kind of wrap this example for today. So there it is. Peanut butter jelly guy's there. Hello world is there. If I stretch this, again, notice how it lines them up. As a matter of fact, look how I stretched it here. I've made it so skinny that now the words hello world are on top of the image. The layout manager is trying its best to help you as you resize this thing to put things in their proper position. Sometimes that's really useful to you. Sometimes it's incredibly annoying to you that you want to say, no, Java, I want that label to be right there. Stop moving it around. And so we're going to explore how to do kind of stuff like that in future classes, like how to really lay things out specifically. Okay? This flow layout is one of several layouts you could use. Okay? So I'm actually going to, just real quick, and I realize I'm not going to get to the grade 12s today, but that's fine. I'm going to show you another one. There's one called the grid layout. Okay? So I can do that. And you can see here, if I use the grid layout, it's a little bit different, right? Like how it's laying it out. Now you can see when I go there, it doesn't put it on top. So there's a difference between flow layout and grid layout in that way, right? And I could take that one out, put in another one. Okay. Oh, group layout is one. And you can see that one in action. And that one actually can't just be done on its own. Group layout is a little bit different. Oh, sorry, it's spring layout. And that's the spring layout. Maybe that's the one you wanted. Notice here I'm moving stuff around and it's not doing anything with it. And then the final one, well, there's more, but the one that by default it uses is the null layout. That was the first one we started with. The null layout has got even, now it's like, okay, I'm not going to put them anywhere until you tell me where to put them. So you have to actually add a little more code, but now you can be a little more in control. You can say, I want it at this x, y coordinate specifically. So we'll get into that in the next sort of couple days as we expand on that some more. But that's going to be where we're going to stop.